This conference will now be recorded.
So very warm welcome, guys. This is Ishant on behalf of Oribasis. I hope all of you are doing good. So today we'll be seeing how you can detect the faces from an image or maybe from a video stream. I'm not saying the face recognition thing here. So yesterday we did see face recognition, how you can recognize the faces, but we sort of, used this API, right, called face recognition, the library face recognition, which was based on the DNN, the deep neural network library, the deep learning library. Today we are going to do something else, right? It's not the face recognition, it's the face detection. So if there is a face, we will detect that. And to be precise, it's gonna be a human face, not an animal face. But what is the difference here? So there will be some predefined trained models. Now, in the approach of artificial neural networks or the deep learning models or the CNN models, right? Now, there are various predefined models available. You can download them, you can use them. So you need not to train those models, right? Now, there are various CNN architectures or models. For example, if you can see over here, right? So LeNet, AlexNet, VGG, GoogleNet, then ResNet, and there are so many other predefined models. You can just download them and you can simply use them in your program. Okay, so it's not that challenging thing for us to understand now. We need not to train the model. They are predefined models. They are predefined with the data. You simply use them in your programs. So today we'll be using one of the such models. So guys, this model I have copied here in my project. So this is this ResNet model. It is going to be a cafe model. It's a cafe model. The extension is a dot cafe model. And there is one more file called a txt file, which is going to have the information on the layers, what will be the input shape. So these are the two files which you will always be getting, right, when you'll be working on some predefined models. There may be different extensions to the different models, right? So what we are going to see today is a cafe model with a txt file having information of the model. Okay, so this will be doing with the OpenCV. So we're going to use OpenCV and we'll see how we can deal with it. So the first thing first is down you import the necessary libraries required, right? So I'll say import the image utils. You can import your basic libraries, let's say numpy as np, then I'm going to import cv2. All right, so these are the libraries which we want to work with. So let's come here and say something known as model, which is going to be your, so this is like model data. It's a dictionary. I created this as a dictionary. So there is something known as a proto txt. It's a key now. So this proto txt I just create as a key, and the value is going to be this file name over here. So let me even show you that from where and all we can sort of get these models. Okay, so I've given this reference link here. So if you can see, this is the reference link. In the reference link, you will be able to find so many other models as well. So guys, you can see here, right? So we have these list of models coming here. You got GoogleNet, AlexNet, Inception from Google, and there are so many other models, right? So you have the URLs and the other details associated with them, right? So there will be some proto.txt files associated, the models, maybe the dense models, the CNN, the mask CNN. There are various different models available here. So I've just shared the reference link here. Okay. Now for the model data, I got a proto.txt file and I got one pre-compiled model available here. So this deep learning model is this RES10. So I'll just get this entire name copied. So I got a dictionary created here. So the first key is the proto.txt and the second key is your model itself. So this is the model which we are going to use. So today our agenda is not to create the model or not to use some libraries. It is to use some predefined deep learning models which are trained and we're gonna use them. Okay. So this is how you have some dictionary where you got a key called proto.txt, which is a text file describing the structure of the model and the model itself compiled into a specific form called cafe model. Now this neural network, right, or the DNN network, right? So I'll say this DNN, deep learning network, or let's say this as a neural net, right, is going to be what? It is going to be CV2 dot DNN. So there's a module called DNN and there is a function called read net from cafe. So read the net from cafe. Guys, you can always read the documentations of the functions which we are going to use here. Now this read net from cafe is going to take two inputs, right? So the first input is this model data of your proto.txt. This is the first input. And the second input is the model data of the model. So what we did, we directly created this neural network rather than writing in the neural network. So you got this neural network done for you. So load the neural network from the pre-defined model. Guys, can I get a smiley as an acknowledgement? I hope this is clear to everyone. So whatever we are on the track is clear to everyone, what we did so far. So for every model, right, you will be shared, some predefined models will be shared with some files, right? And you need to work on some APIs here and there to load those models. So you are actually trying to use a face detection model, right? So it's gonna be a ResNet model in which will be able to detect the face either in an image or in a video. So to begin with, I'll just come here and now read some image. Okay, so let us try to read an image. So I'll say image is your CV2 dot. We got this function called image read. And guys, I'm going to read this image. It's gonna be available with us. So yesterday we got this Amir Khan image, right? So we'll use the same image. Okay. So let's say this ak.jpg. So this is the image which I would like to read. And let us see if the image is read or not. So we'll print down this image. Let's run the program. Okay, I think we got a challenge here. So just give me a moment. Okay, so this is your deploy. So here we are, right? So we got this image red, the RGB value here and there. Now for any image, right? So you will definitely have a shape, right? And if I'll just say print me image dot shape, so when I run this program, you get to see 402 cross 715 cross 3. I hope this part is clear to everyone, right? What is meant by this? So this is the width, the height, the width, and the color channel, right? So RGB. So I just want the height and width of the image. So I'll create a tuple here, h comma w, height and width, which is going to be your image dot shape. So it's gonna be let's say column 2, right? So 0 and 1. So the 0th index becomes the height and first index becomes the width. So coming here, this is the image 715 by 402. So 402 715, right? So you got this image specification. We just got it done. And next is where I'm going to train this model. So model is already trained. I mean to say I'm going to use this neural network, right? So read the image. So this is like dimensions of the image. The next part of our discussion is where we are going to get a binary large object from the image. Okay, so this is something different now. So blob is known as a binary large object. So we are going to convert the image into binary. So converting image into binary. So why is it so? As we need to feed this image to the neural network. So always remember the key principle, right? So neural networks, they work well with the binary part. So we have this RGB values. We're gonna pre-process the image, right? So that's the better terminology to be used now. So binary large object can be obtained from the CV2.dnn. Now this deep neural network is a module in the OpenCV itself, guys, right? So blob from the image. So how it's gonna be? So I'll first of all resize my image to a particular number, right? So I don't want the image to somehow be the same number, which is 402 by 715. I wanna somehow resize the image into an even number. So we'll say cv2 dot resize, right? So this is the function. So after resizing the image into the dimension of 300 by 300, so this is like I resize the image first, then I'm going to say 1.0, this is the scale, and thereafter you're gonna mention the size of the image again. Now this you can just think of pre-processing and normalizing a normalization of image as data for neural network. So I am trying to come up and do pre-processing on the image. So this binary large objects, right, can be obtained from the function blob from the image, right? That's not that quite challenging of a task for us. So can I get a smiley from all of you? Let us try to print the blob as well. So this is your binary large object, right, as compared to your previous RGB values. So that's the difference where we have the data available in the pre-processed form, right? Now the next thing is what? So this neural network, I'm going to give an input to this neural network. So I'll say set the input this blob, right? So this is kind of you can say the input data to your neural network, and now we're gonna feed forward the neural network. So next thing is I'm gonna say neural network dot forward. So forward function is going to basically do the predictions for me, right? So when I will feed forward the neural network, so eventually it's gonna give me the predictions, and my predictions over here are going to be what? So they are going to be the faces in the image, right? So predictions are the detected faces in the image. So guys, can I get a smiley once again from all of you? Till here, is the code clear to everyone? So Shashi says B-log from image function. So Shashi, B-log from image is going to do image normalization. Okay. So what you're doing is you are trying to feed forward one image as an input to the neural network. So we want to do a normalization on the image. So I hope you can recall, right? The process of normalization, the pre-processing of the data. Now, guys, let us try to loop over these predictions, but I will just print the predictions first of all, right? So we'll print down the predictions, run the program. So I get to see these predictions coming up, and if you see the predictions, so I'll also try to say predictions dot shape. Let us try to print the shape of the predictions. The shape is this, it's a 4D array, if you can see now. So 1 cross 1 cross 116 cross 7, right? So guys, this is a 4D array. Now this is going to be what now? If you are planning to work on any model, which is a predefined model. So there will be different ways that you use them. Now, as of now, we are using the cafe model with the OpenCV, but you can even use TensorFlow Keras to get the model from you can read the predefined models from your system, and you can use it in your app, right? So we'll see that in our upcoming sessions very soon. Now, for the model predictions, you need to read the documentations and understand what is what. So you need to be relying on that part. Okay. Now, what I will be doing is I will be iterating for I in range, and this is going to be 0 till, and I'm going to say predictions dot shape of 2. So let me show you where we are trying to iterate. So we are iterating in this 116. So you got this number 116, and I'm going to iterate here. Okay. So for I in range 0 to predictions of shape. Now what I'm going to do is, so this shape of 2 is what, right? So it's basically the kind of a 4D array, and from this 4D array I am planning to extract an attribute called confidence. So I'll write this confidence, which is going to be what? Which is going to be your predictions of 0 0 comma ith array's second index. So first of all, you are iterating in this 116 arrays, and further in the prediction, this particular array's second index will always be the prediction called confidence, right? So we are reading the confidence from the array, and guys, this confidence is going to tell us whether this is a phase or not a phase, right? Now for the confidence to be, it's a mathematical number. Okay, so what I can do is in my model data, if you see this model data, I'm going to take one parameter called confidence. Let's say the value of confidence is 0.5, right? It's a 50% probability. So confidence is a number. This is a threshold, right? So I got a confidence from my neural network, and I'm gonna say, in case this confidence which I am getting from the neural network is let's say less than the confidence in the model data. So I'm gonna skip this. So I'll say continue. So keep on proceeding next. So we are going to skip, right? We are going to skip in case the detection confidence is less than the 50%, right? So this prediction comes out to be okay, that this prediction is supposed to be just the 50% of the face, right? The face may be 50%. Less than the 50% we don't consider, and if it is greater than the 50% part, so what I'll do is I'll create one rectangular box. I'll create one rectangular box, and that rectangular box, right, will plot over your image. So let us see how we can do that. In order to do that, we need to first of all get the box. So box is going to be your detections, which is this predictions of. So 0, 0, ith arrays. So 3:7. Now this is guys all predefined from the APIs, and we are going to say into numpy dot array of this is going to be a list. So width, width and height. So we're trying to draw one a rectangular box, and what we are trying to do is we're trying to get the coordinates for the box. Okay, so this is quite hit and trial basis. Once you know iterate over the data, you find to see where you have to plot. So there will be a starting position of x, starting position of y, end position of x, and end position of y, right? So this is your box, and we're gonna say your box gonna be as type integer. So we get this rectangular box which we would like to draw. So how you will draw this rectangular box, that we'll see, and I'm going to put up the text here. So this text is this confidence which I want to print. Okay, and I want to print this confidence in the percentage. So I'm just gonna say this, and thereafter you say dot format. I'll say confidence multiplied by 100. So if you want to limit the confidence up to 2 digits, right? So for example, I don't want to print 99.999999 so many times, or 23.33333 so many times. So I'll just limit it to the 2 places. So I'll do formatting here. So I'll just say that please limit to 2 places. All right. So this is how you're gonna do a formatting. So text is confidence percentage up to 2 places, 2 decimal places. Now you got the box to be drawn, you have the dimensions of the box to be drawn, and you have the text to be drawn. So what I'm going to do is I'm just going to say cv2 dot rectangle. So you draw this rectangular box, right? And if you want to draw the rectangular box, you're gonna draw it on the same image which you chose. Okay, so image here, then I'll say your start x comma start y, and after this start x and start y, I'll choose the end x and the end y. So this is where we would like to come up and draw a rectangle, right? Start x and start y and x end y. Then I'm gonna say something like the color of the box. So it's gonna be BGR. So this is like red in color. And what will be the thickness of the box? That's like 2, right? So we got a rectangle created, and with this rectangle, on top of rectangle, I would like to put the text. So what I'll do is I'll create a y variable which is going to be start of y minus 10, right? And this is with the condition in case start of y minus 10 is greater than 10. Okay, so in this other way around, I'll say start of y plus 10. So what I did here, so we are trying to plot the percentage if we detected a face, right? And this is going to be a text which will be drawn over the rectangle or below the rectangle depending upon where the face is. Okay. So guys, lastly, I'll say cv2 dot put the text. So this is going to draw the text on the image, right? So this text we want to draw on the image, this text over here. Moving ahead, so you got this start of x comma the y. Then you got, so for the text we need to have a font. We don't need end x and y here. So cv2 dot, so this font I have is font underscore. So we'll take it from yesterday's session and not do much of the coding here. So this is the font, right? Hershey and the duplex. So we'll use the same font, Hershey duplex. And if you want, you can even use a font called simplex. So these are different fonts. You can get it over the Google once again. So the font size, and thereafter what should be the color. So I'm just going to go with 0, 0 and 255. And lastly, once again, the width of this drawn section. And guys, lastly, I'm gonna say cv2 dot image show. So show this image. So let's say outcome, and here we are with the image. So can I get a smiley as an acknowledgement from all of you? Guys, the entire program is in front of you. So where and all the faces will be detected, so it's gonna come up and show us the data, right? I'll even just come here and see group photos. So I'll just try to get one group photo. I think this is good enough. This is a low resolution, so okay. So we'll take some group photo from here. This seems to be a pretty high resolution photograph other way around. All right, so I'll even paste this group photo. So as of now, first of all, we are reading this ak.jpg, right? So let us try to run the program. And guys, this part of the CV2, right? So this will show after the for loop, right? Finally, show the image with drawn rectangles over the faces with percentage. Okay, so did we get to see? Okay, so I'll just do one more snippet here. Not this one. No, it just suddenly went off. So just give me a moment, guys. So going away very soon. Just give me a moment. Something went wrong here and there. So just give me a moment. So guys, I'm just putting this cv2.wait key 0, right? So I'm showing the image. Since the image is not going to be on there, so I'll just put this cv2.wait key as 0. So it's gonna wait. So let us now go with ak.jpg first. So here we are, right? So the detected phase with the percentage coming as 99.80%, right? If you see the accuracy, right, 99.80%. Let us come here and put this as group hyphen photo.jpg. So here we are, guys, with the happy faces. So this is a predefined model, right? And we can now see that all the faces in the group, right, are very clearly detected with a percentage of greater than 95, right? But these two faces somehow they are up to 80 and 60, I think. So can I get an acknowledgement from all of you as a smiley? So if there is an image and you want to detect the faces out of the image, so you can do it very easily with the deep neural networks, right? So this is a cafe model. It's a predefined model and you can very easily use it. Now if we want to convert the same program, so if I would like to use the same program to detect the faces in the real-time streaming, right? So if there is a streaming and you would like to come up and detect the faces, guys, how you will be working on top of that? So I think we need to use our yesterday's program, right? So we are going to use our yesterday's similar program and we'll be able to do that. Let me show you how. So first of all, let me create this new Python file. This goes like our session number 68A. So you somehow need to, not exactly here. So this is session number 67, right? So here we are, right? So while true, you are capturing all of your yes. So let me first of all get this thing here. So CV2, NumPy, and this IM utils and other libraries. I'll just very quickly include, guys. Just give me a moment here. So import your IM utils as well. So we are going to somehow, use the similar program which we have seen earlier in our session number 67A, I think. Yeah, this is the one, right? So while true, you keep on reading the frame by frame from the video stream, if you can recall, guys. So while true, right? So you keep on reading frame by frame from the video stream, and you can just have the object of video stream created outside. So here we are, right? And so here you go. So you got a video stream object, right? You're gonna stream the video from your webcam, and while true, right? So you have this frame video stream dot read. So you're gonna keep on reading all the frames one by one, right? So every frame, if you want, you can resize. So it can go like imutils dot resize the frame, and let's say, just a moment here, the width can go as 400. So from the video stream, you read the data, right? And after reading the data, you got a frame. So one frame itself is an image. Now from here onwards, your same program will continue, guys. The same program has to continue, right? So what we are doing is, so instead of this image read, so you got this guy called frame, right? So this frame may be named as image, okay? So you are reading the image, you are reading basically frame by frame. So you are reading a stream of frames from webcam, and processing every single frame. So you're processing every single frame now. The only thing is this, the entire code goes in this while true, right? So you keep on showing your detected faces. So you keep on showing these detected faces, and we're gonna say the key is going to be your cv2 dot weight key. This is going to be 1 with and your 0x ff. So basically, in case the key is your quit, so if you just clicked on the quit q key, right? So we're gonna break down this while true loop, okay? So that's what we got your CV2 and the deep learning neural network coming up along with. So lastly, I can say CV2 dot destroy all windows, and we can even say your video stream dot stop. So once the loop is terminated, so you destroy all the windows and you stop the structure. Everything else is same. We took our program into the video stream, right? So let's try to run the program here. So here we are, guys. You can see me, right? 100%, 99.9% accuracy. So if I go here or if I go there, we see the face coming in. Can I get a smiley from all of you? This is, I hope, not a challenge. One more phase. Not a real-time phase, right? For a real-time phase, you can detect these blinks. I told you this assignment to be done yesterday. So we did see the face detection part today. Yesterday we saw face recognition, right? So you can have predefined models. They are already trained models. You directly use them. You need not to write your CNN models and try to work on the application part. Okay. So let me push this program over the GitHub. So tomorrow we're gonna come up with predefined models like Google Inception or Google Net. Then we have one session left with the PyTorch training models. We'll have a mask or CNN model, right? So we have a couple of more sessions left as of now. So phase detection with predefined cafe model using OpenCV. So I'm uploading these two files, right? So proto.txt and this cafe model for your usage. So this will not require any TensorFlow here, right? So you can use the OpenCV deep learning neural parts and you can process the data, guys. So thank you so very much. So if you have any query, you can raise the same, and will be there on the WhatsApp, right? And I'll share the project structure soon so that we can have one-to-one meeting, guys. Okay. Thank you, guys. Have a wonderful time ahead. Bye bye. Happy coding.